Now I'm ready. Okay. These are chatty. All right. Just a second. All right. We're ready now. Megan, you missed that one. Got to watch the video.
You call her Megan?
Yeah, Megan. Her name's Megan.
Well, you can call me Meg, but it's so
I'm formal.
Elizabeth?
Elizabeth, yes. Elizabeth Stahl. Who else would? There'd be another one. Elizabeth back there.
Who else is? I'll cut you.
What's your name?
Oh, no, it's Jamie. It's Engleberry. It's Engleberry.
Engleberry. Oh, yeah. That one,
Oh, yeah.
you get the parentheses, Amy. Okay. Our goal today is to wrap up this rectilinear motion problem that we started yesterday so that you can work on the next two. So I'm going to back up a second. This is where we were, and I forgot what the numbers were, so you got to help me out here.
The first row is
Yeah.
positives, negatives, negative, negative, positive.
Okay, those are the signs of the velocity. Do you remember yesterday we said that if the velocity was positive, the object is moving to the right, and when the velocity is negative, then the object is moving to the left. And when the velocity is 0, it's not moving. That's these are the moments where it has come to a complete stop. Okay? Can the velocity ever be undefined for these problems? No. Okay? It has to be going either positive, negative, or 0 velocity. All right. Then what were they for this one? Acceleration.
Negative, 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 positive, positive, positive.
I beat you. All right. So this is acceleration being negative and acceleration being positive. Okay. We talked about the gas pedal yesterday. Remember that? Okay. The accelerometer. And then the brake is the decelerator. Okay. So this was the deal. This particle's speed is increasing on what intervals? We wrote it down yesterday, but can you look at it and tell where it is? Can you look at the picture? When the signs are the same. Exactly. So, right here and right here, the speed is increasing. Okay? So, over here, we are going to say speed is increasing on interval from 2 to 4 and 6 to infinity. Reason is because x prime and x double prime have the same sign. Okay. Then speed is decreasing when they have opposite signs. So that's here and here. So that's why we said speed is decreasing on the interval from negative infinity to 2 and from 4 to 6. Because x prime and x double prime have opposite signs. Okay? Any questions on that? Okay. H. Find the velocity of the particle when the particle's acceleration is 0. How are we going to do that? Correct. Find the velocity of the particle. So find where the velocity, the acceleration is equal to 0. That's right here. That's at 4. Okay. So this problem, what it's asking for is v of 4. 4 is where the acceleration is 0. So this means x prime of 4. You can write either one for this and it works out. So what does this equal? Well, velocity x prime function. So it's equal to 3 times 4 squared minus 24 times 4 plus 36. And what does that give us? 48 minus 96 plus 36. I got negative 12. Okay, so x prime of 4 is equal to negative 12. This is the velocity, okay, of the function when the acceleration is 0. When we're not pressing on the brake, we're not pressing on the accelerator, when our velocity is not changing at all. This is our velocity. We're on cruise control here. Okay. All right, final question. Sketch the path of the particle and describe its motion. Mark the times and positions where the particle is at rest. Okay, so now we're going to draw a picture that describes all this stuff. So here is my line, okay, that this thing is going on. Okay, it's going along this horizontal line. So how the heck are we going to draw this if we're going to draw it on the line? You know what I mean? How are we going to draw it? You can't see it. So we're going to try to do a little fancy thing where we're going to mark off our times and we're going to see what's coming in. All right, so tell me what this thing is doing to begin with. Let's start from time equals negative infinity up to when some action happens.
Negative infinity to 2, it's decreasing speed.
Okay, it's decreasing its speed. What is it doing here? It's moving to the right. So this thing is moving to the right from negative infinity until some time. So it's coming in from the left. Okay? Does it stop at any moment? At any moment? Yeah. At time equals 2, it stops. Okay? So what we should do is we should find out specific values. So help me out here. We're going to find out at x equals 2, at time equals 2, we're going to find its position. We're going to find its position at time equals 4. And we're going to find its position at time equals 6. So I'm going to let you just crank that out on a calculator. Get me those values. You can get your calculator out anyway because we're going to actually use that to validate everything that we're doing. Corey, I'm going to steal this table, this desk behind you.
Oh.
Why don't you move toward this Yahoo over here.
Yahoo!
sleepy. Come on. Get over here.
This is gonna be nice.
Need a faster swivel. Okay. Bitsy, you want to hit that light?
There's an easy way to do it. Yeah, just graph it and then.
Okay. Now, that's kind of a pain, isn't it, to type all those in? Let's be more efficient. So type in your equation, but instead of t's, we're going to use x's. So it's x to the third minus 12x squared. I got to get used to this new operating system. Okay. T cubed minus 12x squared plus 36x minus 20. Now, you could graph it. Okay, you could graph it. But let me show you another trick if you don't know this trick. So I want to find the value of this function at 2 and at 4 and at 6. So there's actually, if you hit the second table set, just to make sure we're in a good spot, it's the window button. So second, then table set. And put yourself as the independent variable, put it at ask. And that dependent, put it on auto. Okay, this is second window. It's setting up of a table. Okay, and then now after you've done that, go to the table, which is it's the one where the trace is. So it's graph. I have my glasses. Second graph. See this table? And then all you have to do is punch in 2, 4, and 6, and you got your answers.
Wow. If you do it the other way, so the independent is on auto and the dependent is on ask, can you like find the x value?
I think so. I think I tried that one time, but I don't remember. Okay? All right, I'm going to actually do it over here. Just let it go. Sorry. It's frozen.
Wait, what? Wow, that was
She told me her calculator was frozen, so I just said just let it go.
I can't believe none of us caught that. I didn't hear it. That was good.
Like that?
It actually is frozen.
Turn it off. Pull out the batteries.
Throw it on the
Okay.
Okay. Now, here's how we're going to show how this particle is moving left and right. So what I've done here is this is my x graph. These are the positions. So this is my x position. This is my x position at time equals 2, time equals 4, and time equals 6. Okay, because those are the magic. This is where the magic happens. So my position is 12, so I marked 12. Position is -4, I marked -4, and then -20. And then I just like putting 0 on here to just have some reference. Okay? So now what I'm going to do is I'm going to put a dot at each one of these. Okay? So the first one, the first place that it matters is t equals 2. right at this moment, I'm going to put t equals 2. At time equals 2, that's where the particle is on the line. So it comes in from the left from negative infinity time up until time equals 2. And at this moment, this is where it stops. And then this is actually where it turns around and then goes back the other way. And then time equals 4, it's at negative 4. No. It goes until 6. At t equals 6, that's when it's going to the left until time equals 6. And then it turns around and it goes back the other way. This magic moment at time equals 4 is when it has got a 0 acceleration. So to describe the path, what we're going to do is we're going to draw it like this. So it comes in from the left, goes up until time equals 12. This is where it turns around and comes back until time equals 6, and then it turns around, and then it keeps on going on and on. And what I've tried to do here is line this one up with this one to show that this is the motion along the line. Comes in from the left. I can put t equals negative infinity here to show that it's all the way from time equals negative infinity. It's coming in from the left. And then through time equals infinity, over here, it's going to the right. Now, actually, most of these problems, you have a set window of time. And you'll see that in the third example that I give you. That's what it is. Okay? Now, I want us to use our calculator to try to see if you can make the connection between what it looks like on the calculator and then what the path is looking like right here. So go back to your calculator, go back to your y equals, and let's graph this thing, graph the position, and see what happens. I'm just going to do a zoom standard first, see if that's anything good. So a zoom 6. Not really that good. Let's try a zoom fit. Zoom fit sometimes works, sometimes doesn't. No, that's not so good either. So press the undo button. I want to always I always wanted now I get in this frame of mind when I write something on the board, I just want to hit undo if I make a mistake. Just not going to happen. All right, so here's how I'm going to do it. You can do it however you want to. I'm going to do a zoom out on this. I went back to the normal screen, and then I'm going to do a zoom out, and then I'm probably going to do a box. So this isn't too bad. I can see where it's turning around. So I'm going to make my box around this, where the action is happening right here. So you can do it however you want to. Just get really good at being able to do this. That's not bad. All right, so this is where I'm making a box around this section because that's kind of where all the action's happening. Okay, this is the position function. This is the position function. How on earth does this graph relate to the blue graph?
You go like this.
Turn your calculator on its side. It's kind of like that, except I think, let me see, I got to do this right. I want to do this. Yeah.
Yeah, that's it.
Yeah. See, I can do that, but you can't do that. Because mine is transparent. So I was able to flip mine. You would have to flip it on its back and look through it. Okay? So, coming in from the left, turns around, goes left, turns right. Okay? All right, so let's look at yours from the way that you have it. All right, how many times does the particle cross over x equals 0? You knew my answer. So look at this. See this picture here? How many times does it hit 0? 3 times. Can you see where they are here? Right here, and right here. It's 3 times that it passes over the 0. These spots right here are when it's negative. To the left of 0, we're negative. Negative, negative, negative. Those are the 3 spots where it's negative. There's 2 intervals where it's positive, 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 and that's here. Positive. Yeah, positive. This is the full interval, and then positive. So those negatives there match up with the negatives there. Positives match up with the positives there. Does that make sense? So it's coming in from the left, going to the right, left, right. Okay? Now what we're going to do is we're going to graph. Oh, yes.
You had like the curve for the positive is 1 and the curve for the negative is 2.
It's this positive right here where it's coming around. It's this is where it's positive here. This curve right here matches up with this curve right here. Yeah, okay, yeah. If it would be, if I put 1 negative right there, that represents that 1 negative there. I did it differently for the negative and the positive. So this is the whole time it's going positive. That one represents this one. And then this time it's on the negative side of 0, and that represents this one. We good now? Thank you, because I wrote it differently for each. Okay, this is the position function. Okay, now what we're going to do is on the same axes we're going to graph the velocity. Okay, so grab your calculator, go to y equals, and now graph the derivative of y1. Graph the derivative of y1. So remember how to do that? Math and derive. And notice we're having the calculator do the work. We could type in that function.
But we're lazy.
But if we made a mistake,
That's it.
then
It's because we're lazy. That's the main reason.
Okay. Now, I forgot to take off the graph of the first one, so I'm going to take off the graph of the first one. Okay. Let's draw the connection. This is big. This is the graph of the velocity. It's the derivative of the position function. Okay, it's x prime. Do you see where this graph is positive and negative and where it's 0? Okay. What do these zeros mean on this graph? What do the zeros mean on this graph? That's the place where the velocity is 0, which means this is where it came to a rest. What do you think those values are? They're 2 and 6. Okay? This is the velocity function. It's 2 and 6. Okay? So when we analyze this, what does this part right here mean? What does that red section mean on this graph? Positive velocity means that the particle is coming in from the right here. It's moving, we should say it's moving right. So it's moving right here and it's moving right here. And that matches our chart. Likewise, what's happening on that interval from 2 to 6? The velocity is negative, which means that the particle is moving to the left. See this? Okay. I wonder what happens here. I wonder what happens when we have a minimum on the velocity function. I wonder what that means. Wait a second. That means the slope of the line tangent to the velocity graph is 0, which means I should have a 0 on the derivative of this graph. What's the derivative of velocity? Acceleration. That means the acceleration is equal to 0 at this value, which is time equals 4. Matches our chart. Okay? So let's graph the second derivative.
Wait, Amy, answer the phone.
Oh, Amy. Come on.
Answer the phone.
I'm not answering that one.
I laughed when you said your answer and Mr. Hawkins.
Okay, let's graph the derivative of the derivative. So now we're going to find the derivative of y2. And I'm going to leave the velocity on here.
Too late for that. Too late.
And here it comes. So the graph of the second derivative is this line. This line represents the acceleration, which means that the function is accelerating. It's positive acceleration greater than 4, which matches. it has a negative acceleration less than 4, and it has 0 acceleration at time equals 4. Okay? And what was the answer to our letter H? Negative 12. Where's negative 12 on this graph? It's the value of the velocity. It's the value of the velocity when the acceleration is 4, or when the acceleration is equal to 0. See how they match up? Okay, you should be pretty fluent with this now, being able to go on and do anything. I'm going to show you something that's kind of cool, though. We're going to step out of function mode, and we're going to go into parametric mode. No, it's really fun. So go to mode and select par. I think you're going to like this. All right, now that you're in parametric mode, press Y equals, and you get this. Yeah, that shows what it's graphing. Yes, it will be important because we're going to put this in here. Okay. So what we're going to do is I'm going to show you that you can use parametric mode to model this particle moving left and right. It's actually pretty cool. So you're going to type in the function in the x1t, and then I want you to put the number 1 in y. So it's going to be t cubed minus 12t squared plus 36t minus. Okay, so it should look like this. Now, when you graph it, it's really exciting. Oh, I'm going to go back to my normal mode here. So I'm going to do a zoom. Oops. Zoom 6. Actually, let's do this for a window. I want to make sure that I can see the whole thing from negative 20 all the way to 12. So go to window and let's do this together. So for my window, I want to go, I don't know, let's go negative 10 to positive 10 and stepping by 0.1. Now these are the times. This is if we could do it, we would go from negative infinity to positive infinity, but we might be here for a while. So we can't do that. X min and X max are the X positions. So I'm at negative 20, so I'm going to use negative 30. My X max was at 12, so I'm going to use 20. And a scale of 1 is fine. And then I'm going to show you this to show that you can see it. I'm going to make this one negative 1. This one be 2. And it'll make sense when we do this. So everybody have all those values? Okay, now graph it. Now if you watched it the whole time, you saw it kind of went here, and then it stopped, and then it graphed here. what it was doing was it was shooting back and forth. Okay? But this is where we're going to use, whoever said that line thing, we're going to use that line thing. This is where it's really fun. Okay, everybody go get the blinking line thing right here. And what we're going to do is we're going to press enter until we get the O without the dash. The O without the dash.
Oh, that's cool.
Yeah. Now graph that. And watch that, baby. Now we're talking. Should look something like this. Go into the motion. What it's doing is it's computing all of the t values going by point 1, computing it and plotting it. Oh, that's pretty good. Yeah. Now, if you want to see it again, you have to actually just retype something. So it doesn't matter what you retype. And then, and you can see it a graph again, but it won't graph. It won't redraw it like this unless you do the graph. Isn't that cool? Okay, so this is a feature. You have to be in parametric mode to see this, and that's the deal. I told you you'd like it. Okay, that's it for today.